Hi everybody, welcome back. Today we're going to go over section 10.2.3, and for this lesson we are trying to solve equations through multiple methods. So our goal for today is to solve an equation usually more than one way. See if you can do it at least two different ways. As you know, there are many different ways to solve an equation, but you just want to whatever method is best for you, is easiest for you, you should probably stick to that method, but at the same time you should know at least another method or two. So let's just read here. It says, so far in this course you've developed several methods for solving equations, such as adding numbers and variables to both sides of the equation, or multiplying each term by a number to eliminate fractions. But how would you solve a complicated equation such as the one shown below? By looking at equations in different ways, you will be able to solve complicated equations quickly and easily. These new approaches will also allow you to solve new kinds of equations you have not studied before. As you solve equations in today's lesson, ask yourselves these questions. How can you see it? And is there another way? So we're going to start off by doing this equation on 10-46. So 10-46, the equation that you see here, we're eventually going to get to that, but we're going to need a little bit more practice. So before we get to that, we're going to start solving the more simpler one, the one with this one right here. Okay, and they want us to solve it in at least two different ways. So I want you guys to pause the video right now. This is something you should all be able to solve on your own. What does x equal? Okay, and solve it at least two different ways. Pause the video and come back when you're done. Okay, so the first method that I solved it was the one on the left in red. And this is what's probably, I'm guessing, the overwhelming majority of you guys, the way you guys solved it. And it's through distributing. So we're going to distribute that 4 into the binomial of x plus 3. We get 4x plus 12. And then it's a two-step equation from there, and you get x equals 2. So that is what you guys are all familiar with. The second method is probably just as easy, but you might not be familiar or too comfortable with it. So if I've got 4, that's multiplying this term right here. Think of this binomial as a single term. If I had this binomial as a single term, and let's just pretend this whole thing was a giant x. If it was 4 times x, well, how would I get rid of this 4 if it was just 4x? To get rid of that 4, I would just divide by 4, right? So we're going to go through the same thought process here. So it's not 4 times x, it's 4 times this parentheses of x plus 3. So it's the same deal. I can still divide both sides by 4, right? Because that x plus 3 is like one term together because it's in a parentheses. So we get x plus 3 equals 5, and therefore x equals 2. So no matter which way you did it, you're going to get the same answer. Okay, so problems 47 through 40, or through 50, I believe. No, through 49 just walks you through that. So if you need more clarification on how I did it the second time, go ahead and read through these 3 problems. But we're not going to do that together. It's not necessary. We're just going to jump straight into, we're going to skip 10-50. We're going to jump straight into 10-51. Okay, so 10-51 has 6 different equations. It says for each equation below, decide whether it would be best to rewrite, look inside, or undo. Then solve the equation, showing your work and writing down the name of the approach that you used. Check your solutions if possible. Okay, so why don't we do the top 3 first? Right, we'll do the top 3 first, and then once you're done with the top 3, I want you to check your answer. So pause the video right now, do A, B, and C. When you're done, come back and check your answers. Okay, so let's look at problem A. Problem A, the left side is being divided by 10, that entire binomial of 2x minus 8. So we're going to do the inverse. Right? So all of these problems as you're solving these equations, you're trying to do the inverse, the opposite. So the opposite of dividing by 10 is multiplying by 10. Okay, so we multiply both sides by 10, and that cancels our denominator of 10 on the left side. And therefore we have 2x minus 8 equals 6 times 10 is 60, and x equals 34. For problem B, before I got to the parentheses, I got rid of that 4 on the outside first, right? So you want to do that first. You want to save the multiplication or division step for last. So I got rid of the 4 by subtracting 4 on both sides. 9 minus 4 is 5. And then I got x divided by 3. I just rewrote it as a fraction just because it helps me understand or visualize that it's x over 3. So what's the opposite of dividing by 3? It's multiplying by 3. And I want it to be able to cancel like that. So my right side, 5 times 3, x equals 15 is the answer. For problem C, I wanted to get rid of the radical. The opposite of square rooting is to square. So I'm squaring both sides. And I'm squaring that binomial of 3x plus 3. So that's going to get rid of the radical symbol and leaves me 3x plus 3. And then on the right side, I got 6 squared is 36. And again, from that point on, it's just a two-step equation. X equals 11. All right. So at this point, I want you guys to attempt the last 3 from this problem, D, E, and F. And then when you pause the video, when you're done, come right back. All right, so for problem D, we notice that the left and right sides have the same base of 7. So therefore, just like we did in the last lesson, we just set the exponents equal to each other. And as we solve for x, we begin to isolate x. We'll find that x equals 3 halves. For problem E, we're going to subtract 4 on both sides first. And then that leaves me with x squared equals 5. To get rid of that radical, I've got to again do the inverse. The inverse of square rooting a number is squaring the number. So we've got to square both sides. And therefore, x equals 25. For problem F, the lowest common denominator here is 9. So I'm going to multiply all 3 terms by 9. And that's going to give us the following line of 3x minus x equals 54. Solve for x, we get x equals 27. Okay, we've only got one more problem to do, guys. Today's lesson is relatively short. And the last one here is 10-52. Okay, so it says, consider this equation of the quantity x minus 7 squared equals 9. Part A says to solve it using all 3 approaches that you've studied in this lesson. And then it says you want to compare your answer to your teammates. Obviously, you can't do that. So solve it in 3 different methods, and then at the end, explain which method you think was the most efficient, and tell us why, or tell me why. Okay, so just write that down in a brief sentence. So once again, pause the video, solve that same equation in 3 different ways. Come back and check your answer when you're done. Alright, so here are the 3 ways that I solved them. The first one in green, just solving an equation, square rooting both sides, and solving for x. So the square root of 9 is going to be a positive and negative 3, right? So when we have the 7, once I get rid of that negative 7 by adding 7, I'm going to add 7 to a positive 3 and to a negative 3, which gives us the answers of 10 and 4. The second way I did it was I multiplied the binomials and then I put it in standard form right there in red. Then I used a quadratic formula and I got 10 and 4 as well. Not 10 comma 4, but 10 and 4. The third way is the same, is just still derived from the standard form of the quadratic equation right there. But then I factored and I got 2 binomials, x minus 10 times x minus 4, using the zero product property, I set them both equal to 0, and I'd get x equals 10 and x equals positive 4. So, which method did you guys think was the best? hopefully you would agree with me when I say that the first method in green is the best. For me, that's the easiest, right? Second easiest for me would probably be to factor. And then a third way is, the tried and true guaranteed ways. Always use the quadratic formula. That will usually get you a pretty solid answer. Okay, so we haven't addressed the actual problem that was first introduced in the lesson. So to close today's lesson, I want you guys to attempt to solve that equation right there and see what you come up with. All right? If you have any questions on that, let me know. Otherwise, that's it for today, guys. Hope you guys have a great day, and I will talk to you guys soon.